Welcome to our video on 3.4, estimating margin of error. So here's our big term here, margin of error. We've mentioned it a couple of times, but we never defined it, and you'll notice a lot of language that's similar, but here's our chance to really make sure that we include all of that here. So our big idea right away, margin of error. What does that mean? The margin of error describes how far at most we expect the estimate to vary from the true population value. So what are we thinking about? In statistics, we're always trying to predict something. What is that something that we're trying to predict? We're trying to predict something about the population. The most straightforward example is if we're trying to predict an unknown, something about the entire school, something about the people who are going to vote, something we don't yet know. And we get an estimate, usually from a sample, and we don't expect that sample to be exactly correct, as we talked about earlier in chapter 3. How far away do we expect it to be? And that's what the margin of error describes. So let's underline margin of error. Huge term in statistics. And then, importantly, we want to put this in a sentence, again, that interpret. So how do we interpret this? One way is, and if we reorganize this a little bit, it's fine, but what are the key pieces? We expect the true value, which I noted here, it's almost always a mean or a proportion. So either an average or a percent. We expect that true value to be within whatever the margin of error is, that many units of the estimated value. So that's how far we expect it to be away from whatever we estimate. And we'll see an example here on the back. Now, how do we make this margin of error? Now, this is actually a pretty short calculation. Most of it is involved in things that we learned in chapter 1, which is to take a sample, find the mean and standard deviation of that sample. So that's all chapter 1. What we do is with the mean and the standard deviation of the sample. Sometimes we'll do that ourselves. Sometimes it's done for us in a margin of error question. To complete that part, we multiply the standard deviation by 2. That is your margin of error. And you might be wondering, why 2? Why is 2 special? And that's a question that's going to wait for later on in the course. It's actually not even chapter 3. In chapters 4 and 5, we'll see why it happens to be 2 for the standard deviation. There's a little bit of math behind it, and we'll keep revisiting this. So whenever we have the standard deviation, multiply that by 2, and this is your margin of error. So we can calculate our margin of error, we can interpret our margin of error by putting in a sentence, and then last, we want to be able to make decisions with our margin of error. And that is a value plausible? So for example, is it plausible that the average height of a school is this? Is it plausible that this percent of the population will vote for this candidate? We check to see if that is within the margin of error. Notice we're not using the word possible, even though it's very close, because we know that our estimates might always be wrong. But this is essentially how much we would expect our estimate to be off by. Again, we're using that word expect. And so if we want to see if a value is plausible, we check to see if it's within the margin of error. So if it's closer in the margin of error, then it's plausible. It's not confirmed, it's not proven, it's just one of the possible values. And if it's not within, then it's not a plausible value. For right now, we're going to use this word plausible until in later chapters we talk about some better language for that. So 3 things here. Calculate the margin of error, interpret it in a sentence, and then check to see if the value is plausible. So let's flip this over and do some examples with this. There's a lot of information here. We need to pick out the important part here. Many people can roll their tongues, but some can't. Javier is interested in determining the proportion of students. So again, we're thinking proportion is percent at his school that can roll their tongue. In a random sample of 100 students, it determines that 70 can roll their tongue. This dot plot shows a simulation, and this is actually not much of a concern of ours. But we have here mean, the standard deviation. That's going to be our key pieces for this example. use the results to approximate the margin of error. So how do we calculate that margin of error? So we have our mean and our standard deviation. Now this is a proportion which we know means a percent. So if we'd rather convert these both to percent, 70.1%, 4.8%. So if you'd rather do that, you absolutely can. And a lot of times it's going to be easier to put sentences in there when we just deal with this as a percent. That's only if it's a proportion. If it's a mean, we do not turn it into a percent. So a proportion is a percent. A mean stays in whatever units we're talking about. And so we know here, margin of error is always standard deviation times 2. So margin of error here is going to be 2 times 4.8% is 9.6%. Interpret that margin of error. So now we go back, and here's where the mean really comes in handy here. The mean was our estimate. We're estimating that 70.1% of students can roll their tongue. So that's what we expect. This is how close we expect to be. So we expect whatever we're trying to estimate. The proportion of students that can roll their tongue. We expect and here's where we want to start using the language true. We don't know it, it's unknown, but it's the true proportion of students who can roll their tongue to be within 9.6% of our estimate of, what did we estimate? We estimated 70.1%. So what are we looking for here? What are we trying to estimate? The true proportion of students, in this case, roll their tongue. We expect it to be within this percent of our estimates. So kind of 3 pieces there. So this is calculate the margin of error, interpret that margin of error. Then, is this plausible? Is this estimate plausible based on our data? And so we want to decide, is this reasonable? What we can do is we can always, this is what I recommend, find the lower and upper bound of our estimate. We really think of this as 70.1% plus or minus 9.6%. So think of it as a plus or minus. Figure out what that plus and minus are. 70.1 minus 9.6, 70.1 plus 9.6. Figure out what that plus and minus are. That's out of the edges of our margin of error, and if it's within that, it's plausible. If it's not, then it's not plausible. So here we've got 60.5% and 79.7%. So these are like the boundaries here. So is it within this? So we can say here 75% is between 60.5% and 79.7%. So it is plausible. It's within the margin of error. So it's plausible. And then last, how can we decrease the margin of error? That would be to decrease the standard deviation. We know to decrease the variance, we could increase the sample size.